Hello, everyone. Hello, Locus Chain investors. My name is David Wang, and I'm a Senior Business Development Manager at Bloom Technology, which is the development of Locus Chain. It's glad to meet everyone here. So without further ado, I think we should start the webinar session. Just to give you a brief introduction of what Locus Chain is the next generation layer 1 public blockchain. We still have some participants joining as we speak. I would like to welcome you all and thank you for joining our webinar session today. It's truly an honor to be able to present to you the fantastic technology of Locus Chain, and I really look forward to introducing more and more about our technology and to discover the true wonders of what this technology can do. So we're going to actually do a series of webinar sessions because the technology is really complicated. There's a lot of different technologies involved. And if we jam that into a single webinar session, I don't think the webinar session itself is going to be lengthy. So we're going to split the webinar sections into various sections and explain different technologies per session. So we'll be focusing on key technologies that make Locus Chain the most scalable and fully decentralized layer 1 public blockchain. And these technologies include ledger structure of Locus Chain, which is the DAG-based account-wise transaction chain, verifiable pruning, and dynamic sharding. But today, for today's session, we're going to be focusing specifically on verifiable pruning. So without further ado, before we deep dive into the webinar session, I would like to share with you a video that better explains Locus Chain.
Our world is formed of many transactions. All activities with senders and receivers can be considered as transactions. They include activities such as sending and receiving money, purchasing and selling real estate properties, and others. Even if it doesn't involve money, sending email documents or concluding a contract among companies can also be transactions. The credibility issue arises when it comes to transactions. Let's assume A lent $100 to B. A honestly recorded this on a ledger, and B dishonestly recorded that B received $50. In this case, how can we tell which ledger is reliable? Here, the third party appears to immediately guarantee the transaction. The third party intervenes in the middle and records the transaction of A and B. The truth can be distinguished based on the ledger the third party makes the record on. However, this system does not guarantee completely transparent transactions. B can manipulate the ledger by conciliating the third party, or B can secretly steal the third party's ledger and change the data. Most of the transactions that we currently transmit and receive are based on this centralized system. For example, when you send email, the send history becomes recorded on the company's server that provides the email service. However, as mentioned earlier, anyone can hack the central server and tamper the data. And if the central server shuts down from problems in the network, there is a chance that all transactions will become interrupted. This is called single point of failure. Basically, the whole system can shut down even if just one spot in the system fails. Accordingly, blockchain is the current technology that is receiving the spotlight. In blockchain structure, all the network participators share their transaction history instead of relying on the centralized system. This is called decentralization. In blockchain, everyone reaches a consensus on which content to include in the ledger and synchronizes each other's ledgers. Even if someone tries to tamper the data, the person must receive the agreement of the other participators again because everyone shares the same ledger and the data is encrypted. Therefore, blockchain transactions can be viewed transparently. However, what happens if the network participators increase and transactions occur more frequently? The speed slowed down from asking each other and drawing conclusion. Network overload occurs from the increased traffic, and the ledger increasingly expands over time. The demand keeps increasing, but the processing capability is limited, which causes delays. We call this the scalability issue. Several blockchains have focused on increasing the speed to resolve this issue. For example, there is a way to limit the number of people who participate in the decision-making process. This may cause the speed to increase dramatically because a limited number of people just needed to communicate with each other and update the ledgers. However, an absolute majority of people cannot participate in the decision-making process and also cannot possess the ledgers. In other words, increasing the speed causes decentralization to weaken, when this is a significant trait of blockchain. However, what happens if the decision makers choose to manipulate the ledgers? And what if the server of the representatives shut down? The more you restrict the number of network participators, the higher the chance of problems such as manipulation, network shutdown, etc. to occur from collusion and hacking. This is the dilemma of blockchain. Strengthening decentralization causes the scalability to decrease, and increasing the scalability causes the scalability to weaken. The blockchain projects that have been released so far had to choose one of the two paths after stumbling upon this dilemma. When these projects had to make the inevitable decision, Locus Chain filled in the gap between these two mountains with its high technology and created a massive mountain instead of choosing to climb up one of them. It has filled the gap between these two mountains to secure decentralization and scalability at the same time. How was this possible? Locus Chain implemented BFT consensus on the AWTC ledger structure that can be managed by accounts. On top of this, it implemented the Verifiable Pruning technology, which allows data verification even when the data of the ledger becomes deleted. It also implemented the dynamic sharding technology that divides the network into shards. Through this, Locus Chain resolved the dilemma between decentralization and scalability. We will explain each technology step by producing separate videos, so please look forward to it. As you can see, Locus Chain is a blockchain that allows fast transaction processing even when everyone shares the ledger and has extremely small ledger size or network usage. Because of this, anyone can operate Locus Chain on their mobile devices. This is important because it's not only resolved the dilemma simply in a functional way, but also increased the usage so that anyone can participate in the network. Locus Chain is called a practically usable public blockchain because of its high usage. Locus Chain that resolved the dilemma. How can it be used? Shall we take IoT device, the big data-based artificial intelligence, as an example? This device endlessly transmits and receives communications which create extremely small unit of transactions called microtransactions. With the current centralized system, it is difficult to manage thousands of small transactions. Not only problems with tampering, hacking, server shutdown, but also cost issues arise. Moreover, in the 5G era with high-speed communication, many transactions, data, and costs may occur beyond our imagination. Blockchain that acquires both decentralization and scalability is essential for the future. The blockchain that cannot specify the target of attack and one which the entire system remains unaffected even if one of the participators shut down. The blockchain that can be applied in real-life situations from its lightweight and fast speed. Locus Chain has completely changed our future by resolving the blockchain dilemma. A world where transactions among people and among objects can be safely processed, even without any guarantee from others. This is the credit revolution era that Locus Chain will establish. A revolution that creates new politics, society, and culture beyond the emergence of simple technology. As a result, things you have never dreamed possible becomes a reality. This advances the entire humanity. This is the kind of future Locus Chain aims to build.
So I do hope that you enjoyed the video. And so before we deep dive into the Locus Chain's verifiable pruning, I'd like to spend a little time to explain about the current state of the crypto market and also the blockchain industry. Currently, the crypto is still at the very early market, and the market is set to grow further, but the public needs to know about the aware of the blockchain industry. However, unfortunately, the blockchain industry is still facing critical issue, and that issue is scalability. The early blockchains are extremely slow, and their fees are very, very expensive. And also, operating a node is costly, and some blockchains are raising security risks due to the low number of nodes that are participating on the network. So after I explained all this, but before we move on, I'd like to cover the basics of what ledger and what node is, so that you can understand better about just how great the verifiable pruning technology is. As I explained earlier, the critical issue about the blockchain is slow performance, expensive fees, and security risks. So what is a ledger and what's a node? A ledger in blockchain is essentially a record of all transactions linked in blocks one after the other. Blockchain is the distributed ledger system that distributes that particular ledger on the participants on the network. In this case, nodes. This blockchain concept was very fascinating because of the concept of decentralization. But as more transactions accumulate, ledger becomes bigger in size and puts more burden on nodes, and thus the blockchain is not considered scalable. To provide you with some examples using Ethereum, the current Ethereum size ledger today is over 820 gigabytes. What that means is when you want to participate on the Ethereum network as a node, you need to have at least 820 gigabytes of hard drive, or at least 1 terabyte, because the ledger itself is only 820 and you need more space to run various programs. Now, the hardware itself is going to be extremely expensive when you think about the hardware that could store 1 terabyte of storage space. The hardware itself is going to be costly, and to solve this problem, blockchain developers have come up with a solution called pruning, which essentially is deleting old ledger data to reduce the size of ledger and allow the nodes to have smaller storage space. Pruning itself is actually not a very new technology, I would say, and it's not the only, Locus Chain is not the only technology that's using the pruning technology. But the critical problem with the pruning is that when nodes really want to validate the data of old transactions, it's impossible to validate the data that is deleted. So that raises the question of scalability and also security and also decentralization. Another issue with traditional blockchain networks like Ethereum is that all nodes must possess identical ledger, regardless of whether some of the data on the ledger are irrelevant with the node. This means that all nodes must have high computational power, and if the hardware does not qualify that required spec, it cannot become the node. So what's different with Locus Chain's verifiable pruning versus the regular pruning of other traditional blockchains? Locus Chain's verifiable pruning has solved that issue so that even if the ledger is pruned, you can still validate the old data. Since the nodes can verify data without storing the entire ledger, all the nodes on Locus network does not require to possess the identical nodes. Ledgers can be pruned differently depending on the relevancy of the data, and yet it can still be able to validate and verify the data of the entire ledger. And this significantly increases the flexibility of node requirements. So let's watch a video that explains verifiable pruning. But before I go into verifiable pruning, I'd just like to reiterate on the various different technologies of Locus Chain. Verifiable pruning is just one feature of technology of Locus Chain. And Locus Chain also has different features such as dynamic sharding, and it also has a very unique ledger structure called the DAG-based account-wise transaction chain. We will cover the DAG-based account-wise transaction chain and dynamic sharding on a different webinar session.
If so, what is Locus Chain's verifiable pruning? Verifiable pruning is an exclusive technology to Locus Chain that can verify validity of the previous data with only the latest hash value. Using a mathematical data structure, hundreds of gigabytes of data can be reduced to tens of kilobytes in a high-speed blockchain network, while providing complete data verification. In terms of the increasing accessibility of node operation, verifiable pruning is a technology that has innovatively resolved the problem of the increasing ledger size that had to be resolved for the blockchain to be used in real life. The small storage space required for node operation means that the node can be operated by anyone at low cost of participation, enabling legitimate decentralized blockchain, which can also be used for low-spec devices.
So as the video explained, keeping the ledger size small means that the node can have a much smaller computing power. Unlike Ethereum nodes, which require high storage capacity, high electric consumption, and high computational power, Locus nodes can run on much smaller devices such as mobile phones, and even on some of the much smaller devices that's going to be shown on the next video. What this means is that the entire network of Locus Chain consumes much less electricity than Ethereum or Bitcoin, because the electric consumption of node of Ethereum or Bitcoin is so much significantly much higher than what you see before you. All these devices can be technically and potentially become a node of Locus Chain. Bitcoin or Ethereum pretty much consumes electricity equivalent of a country. So lower requirements on nodes ultimately means lower costs of nodes, resulting in much more nodes to participate on the network. And this will ultimately increase the security and stability of Locus Chain. Lowering computational powers of nodes have other benefits because it can run with other programs simultaneously without slowing down the device itself. Recently, Locus Chain have succeeded in developing a game chain, a game version of mainnet where a computer themselves run the node and the network itself replaces a function of the server so that an online game operates essentially without the server. This is a huge technological breakthrough in both blockchain and gaming industry, and we will see much more accomplishments of Locus Chain. So I just like to share with you another video of another accomplishment of Locus Chain due to verifiable pruning. Like I explained, because the node itself has really low computational power, the node can run with other programs simultaneously, which means that you could run a computer game and a node program at the same time, and that computer can still act as a node. What this enables is that the computer game itself can be played while the node itself acts like a server.
Hello, I'm Yuri Kim from Bloom Technology, and I'm participating in development of Locus Chain's game platform as a developer. Let me introduce a new platform, Locus Game Chain, that I'm working on. GameChain is a world-first project that replaces online game server with Locus Chain's public blockchain network to build a new blockchain-implemented game platform. GameChain is based on Locus Chain's blockchain technology. GameChain is utilized to enable online gameplay based on the decentralized network of Locus Chain without the need of a separate centralized server. A demonstration of GameChain will be conducted through the network gameplay of Kingdom Under Fire. This is the GameChain launcher that implements blockchain technology. We will initiate the game. Previously, in order to enable multiplayer mode, a Wargame server was necessary to find and match players, but the server is no longer operational. However, the GameChain replaces the matching server function for online battles, therefore the Wargame server is no longer required. Locus Chain blockchain network will support the online multiplayer battles on behalf of the servers. Other players can participate in the game by receiving information through the network. The game has been created. When the game is created on the game chain, information regarding matchings of the created game will spread throughout the users around the world through the blockchain network, allowing other users to check and participate in the game. Kingdom Under Fire can support up to 8 people per game, and for this demonstration, we have 4 participants. We will initiate the multiplayer gameplays through the Locus Chain game chain. The game has started. The real-time gameplay of the multiplayer modes for 4 participants runs smoothly as if the game was using Wargame server. Locus Chain is the first blockchain technology to have DAG-AWTC technology with BFT consensus. The node itself is very light, but its performance is exceptional. Therefore, it operates without putting too much burden on the PC and consumes extremely low resources and CPU usage here, and players will not notice the operating nodes. The game has ended. The results of the game will be recorded on the network of the blockchain. Locus Game Chain is minimized on tray, making it convenient to turn it on and off. Locus Chain's game chain nodes operate in the background during the gameplay, but their resource usage is insignificant. Locus Chain's game chain will prove its value as a game platform with more and more new game content by utilizing the technology of the decentralized next-generation blockchain Locus Chain. As you can see, Locus Chain, which is basis of game chain, is light and fast, and it is designed to perform various functions. Previously, a large centralized server was essential to play online multiplayer games, but now it can be achieved with nodes. It will connect the world. Anyone can fairly enjoy and participate in various contents on blockchain network, including games. That's it for the demonstration of Game Chain. Thank you for your interest in Locus Chain. See you next time.
So I hope you enjoyed that video. The reason I share with you the game chain is actually a game version of the Locus Chain mainnet version. And what's so significant about the game chain project is it's actually the very first blockchain project where a blockchain function actually replaces a function of a game. Now, we all heard of various different blockchain games, but essentially the blockchain games that are existing right now is really the blockchain technology itself issuing cryptocurrency that really sustains an ecosystem of the game. But the blockchain technology does not really support a function of a game, whereas the game chain is completely different because it actually replaces the function of a server for a typical particular online game. And that's a unprecedented breakthrough, I would say. And that is really something that the world really look forward to, because maintaining a server for an online game is very expensive, and there's a lot of very different verification cost involved. Whereas if you use all that with a blockchain network, you save a lot of money and you save a lot of time and you save a lot of resources. So the game chain is actually, we just recently succeeded in a focus group test, and it will be launched in probably a month or two. So this is really a spectacular demonstration of what Locus Chain could achieve in the future. Game Chain is just one of many projects that's really utilizing the technology of dynamic sharding, verifiable pruning, and the unique ledger structure. So there are a lot of different technologies involved, like I said, and today we went through verifiable pruning, and I hope I made myself very clear about just how unique that pruning technology is compared to the existing pruning technology that was adopted by the very early blockchain technology. I hope we really had a very fruitful and informational webinar session today. That's all I have about verifiable pruning. The next session will cover probably dynamic sharding and also the ledger structure of Locus Chain, and plus many other different technologies that Locus Chain possesses. I really hope that this webinar session will really enlighten you about the technology behind Locus Chain and why Locus Chain is the legitimate next generation blockchain platform. Thank you so much for tuning in, and I look forward to introducing the next technology of Locus Chain in our next webinar session. Thank you and goodbye.